Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this session we are going to evaluate this integral where we have the limits from 8 pi to 15 pi and the integrand is absolute value of cosine x, right? So let us call this integral as I, right? Now, in order to evaluate this integral, we have to make use of two important concepts. The first one is the concept of periodicity of functions, and then we'll make use of the concept of sign convention of trigonometric functions in four quadrants. So let us first denote the integrand by f of x. So f of x is mod of cos x, right? And we know that the period of mod of cos x is equal to pi, right? And from an important property of definite integrals, we know that if we have a periodic function, say f of x dx, and the lower limit is say p times t, and the upper limit is q times t, where p and q are some integers and t is the period of this function f of x. Then the value of this integral is given by q minus p times the integral from 0 to t f of x dx, right? So now if we compare this integral with this one, then we can see that t is the period of this function f of x, that is mod of cos x, right? So the value of t is pi, and here the value of p is given by 8, and the value of q is given by 15, right? So this integral I now takes the form that is q minus p times the integral from 0 to t f of x dx. So we have q minus p, that is 15 minus 8, and here we have 0 to pi, because the period of mod cos x is pi and f of x is mod of cos x, and here we have dx. So 15 minus 8 is 7, and here we have 0 to pi and mod of cos x dx. So now to evaluate this integral, we have to make use of the concept of sign convention of trigonometric function in four quadrants, and here the trigonometric function is the cosine x. Now see, if we have the four quadrants, here we have 0, here we have pi by 2, and then we have pi, this is 3 pi by 2, and here we have 2 pi, right? So this is the first quadrant, this is second, this is third, and this is fourth. And we know that the cosine function is positive in the first quadrant and in the fourth quadrant. So cosine function is positive in the first quadrant and in the fourth quadrant, and cosine function is negative in the second and third quadrant, right? So now here the limits of integration are from 0 to pi, right? So we have to go from the first quadrant to a second quadrant, that is from 0 to pi, right? And here we can see that when we go from first quadrant to second quadrant, then the cosine function changes sign from positive to negative, right? So at this point, that is pi by 2, we have to break this integral into two parts, right? So we have to now write here first integral, that is 0 to pi by 2, where the cosine function is positive. So here we have mod of cos x dx, and the second integral is from pi by 2 to pi, and here we have mod of cos x and dx. Now let us make use of the definition of a mod function. Now mod of p is defined as positive p whenever p is greater than 0, and mod of p is 0 whenever p is equal to 0, and mod of p is negative p when p is less than 0, right? So now if we replace p by cos of x, then the definition of mod cos x in the interval that is 0 to pi. So here we are considering only the interval that is from 0 to pi, right? So mod of cos x is positive cos x whenever cos x is greater than 0, and mod of cos x is 0 whenever cos x is equal to 0, and mod of cos x is negative cos x whenever cos of x is less than 0, right? Since we are restricting ourselves to the interval that is 0 to pi, when cos of x is greater than 0, it implies that x must lie between 0 and pi by 2, right? So when x belongs to the interval that is 0 to pi by 2, then cos of x is greater than 0. It means we are in the first quadrant. And when cos of x is equal to 0, it implies that x is equal to pi by 2, right? Because cos pi by 2 is equal to 0, right? And when cos of x is less than 0, it implies that x belongs to the interval that is from pi by 2 to pi, right? So this interval indicates the second quadrant, right? So in the first quadrant, cosine function is positive. At x is equal to pi by 2, cosine function is 0. And in the second quadrant, the cosine function is negative when x belongs to this interval, right? So let us here replace mod of cos x by positive cos x when x varies from 0 to pi by 2. So here mod of cos x is positive cos x, and in this case when x varies from pi by 2 to pi, mod of cos x should be replaced by negative cos of x. So now let us write the integral I as here we have 7, then we have 0 to pi by 2, and mod of cos x is positive cos x dx, and then we have pi by 2 to pi, and here mod of cos x is negative cos x and dx, right? So now we have two simple integrals here. The integral of cosine x is sine x, and the limits of integration are from 0 to pi by 2. And then here we have the negative sign. The integral of cosine x is simply sine x, and the limits of integration are from pi by 2 to pi. So now let us simplify it. We have 7. The first will take here x is equal to pi by 2. So we have sine pi by 2 minus sine of 0. And then we have sine of pi. And then we have sine of pi by 2, right? Okay, so now here we can write sine pi by 2 as 1, sine 90 degrees is equal to 1, sine 0 is 0, and sine pi is 0, sine pi by 2 is 1. So we have 7, then we have 1, 1 minus 0 is 1, 0 minus 1 is minus 1, so we have 7, this is 1 plus 1, that is 7 times 2, that is equal to 14, right? So the value of this integral is equal to 14.